The Sky This Month with your host, Dave McDonald.
Welcome to The Sky This Month for February 2022. And if you didn't catch last month's show, Happy New Year. Always great things going on in the sky in the nighttime. We have all kinds of things that you can go out and see from your backyard or maybe a short drive, because some of the things we're going to be talking about, you need a fairly low, flat horizon towards the east when the sun is rising or towards the west where the sun is setting. So to start off February, you're going to have probably for the first week in February your last decent views of Jupiter. Earth's motion around the sun and Jupiter is in orbit, and Jupiter is going to be falling into the glare of the sun. And on that same note, hopefully you got to enjoy some nice views of Saturn for all of fall, but in December, January, we had some views of Saturn, and it is going to be in what we call conjunction with the sun on February 4th. So a couple of weeks either side of February 4th, you're not going to be finding Saturn. But it's going to be emerging in the morning sky, and you're going to be able to see some glimpses of Saturn and watch it as it rises higher and higher in the morning sky as the months go on. We have great things to tell you about Venus in the morning. It's going to be reaching its maximum brilliance like in a lot of years, which is very cool. And we have Mars showing up in the morning sky as well. So a lot of very cool things. And towards the end of the show, we're going to focus on what's called the winter hexagon. We're going to share some constellations and stars. And what does the color of the stars mean at the end of the show? Well, I have with me once again Seth Roop, who is a sophomore at UNH, and that's spelled UNH. Welcome again to the show, Seth.
Thanks for having me. It's a pleasure to be here.
You are no stranger
No.
to our show. And so I understand we had a great Christmas present this year, that on Christmas morning something amazing in terms of the amount of time we've been waiting for it to happen happened.
Indeed.
So tell us, what is that, Seth? What was our Christmas present?
Well, normally gifts are being given to us. This one was going away from us, far away from us in space. The James Webb Space Telescope was launched early on Christmas morning, on its way over 1 million miles away from Earth to its spot at Lagrange Point 2, where it's going to be doing observations into far out space in place of what the Hubble telescope, which, as many of you may know, has come to the end of its scientific lifetime.
Yeah, and that's kind of sad. Hubble has done such an amazing job. I mean, it's got a little more life into it. Some people are, thinking maybe 5-ish years or so. But, as parts wear down, because there are some mechanics involved there, and obviously some computer equipment, solar panels. But as things deteriorate over time, there's no more repair missions. The space shuttles have been retired. We can't get out there. It's around 400 miles up. And so when it's dead, it's dead. So now we have the James Webb Space Telescope will be taking over and seeing even deeper. So tell us about a little more about James Webb, Seth.
Yeah. So it's a project that's been in works for years and years and years. Tons of scientists and engineers have been working on this project to make this all work. It's very large. I don't know how well you can see in this picture. If you see those shapes at the bottom, those are people. So you can see it's rather large. And the mirror, you can see those yellow hexagons as well. Those are the mirror arrays. And you can see on the right an illustration of how that looks when it comes together. And I believe the mirror is, it's rather large. It's 6 meters, I think, in diameter.
Yeah, it's in the realm of 20, 21 feet.
Yeah, so it's nothing to sneeze at. It's some heavy-duty stuff.
And you better not sneeze on it.
Yeah, because you might break it.
Yeah, that really is impressively large when you look at those human beings down there at the bottom of and that's and a lot of people ask, well, this thing when it's deployed, and you can see that picture on the right, is about the size of a tennis court.
It's pretty big.
It's big. And Hubble, not to say that a school bus isn't big, but Hubble is about the size of a school bus, and here you have a tennis court that you can probably park maybe 10 school buses on.
Right, and that brings its own set of challenges when you're dealing with something so large, especially if you see that on the picture we were looking at, the deployed telescope, which it can actually bring up a full screen picture of. If you see that film-like material at the bottom that David is talking about being almost the size of a tennis court, that is a very, very thin material. That's the sun shield to protect the mirror from the brightness of the sun, because that would stop the telescope from functioning properly. If that rips at all or tears while it's being deployed or while it's traveling through space, that would be a catastrophic failure for the team, and the project would be ruined. And so that's one of the challenges for the teams that are working on this, is how do we get this to work without messing up a single thing, without anything getting damaged in this whole process, or everything's ruined. So really, it's incredible, impressive stuff.
And it looks like there's like 5 layers of that thin material there. Yeah, because when we're looking back to 13 and a half billion years, back to the first stars, the first galaxies, the heat signature that left there, and James Webb is primarily an infrared-oriented telescope, so reading heat signatures, and the heat that it's trying to detect from these earliest stars and galaxies is very, very, very tiny. So in order to receive the heat and detect it, it itself has to be really cold. I mean, we're talking just a few degrees above absolute zero is what it needs to be cooled to.
And so the telescope itself, it's as we are recording this, it has almost reached its destination of Lagrange point 2, which I will talk a little bit more about in a second. Almost 1 million miles away. And once it's there, for actually the first like 6 months or so that is out there, it will not be taking measurements and data and images and communicating that back. It will be preparing to take measurements, cooling down, making sure that everything is prepared to actually start collecting data. So that actually will not start right away when it's in place, but a couple months later.
Yeah, because apparently it takes a while for it to cool down. So as we speak, as Seth mentioned, we're recording towards the end of January here, and it is around negative 330, negative 340 degrees Fahrenheit, and we got to get down to somewhere in the vicinity of negative 455 degrees Fahrenheit. So it's got a lot of cooling yet to do.
And the colder you get, the harder it gets to get it cold.
Yeah,
so.
yeah. It's like, easy. The first 100 degrees are easy to cool off.
But the last half.
But the last, but the last half of it is really small. So what are we looking at here, Seth? This is looks like pretty interesting.
Yeah. Well, we just want to take a look here. This is just the path that it took when it was launched from Earth on Christmas Day in the morning. And you can see the path that it takes. It has a little strange little tail at the end of it. That's part of the maneuver that they have to do in order to get it properly into. You see the little L2 in the bottom right corner. That stands for Lagrange point. That's its final destination where it wants to be. So you see it kind of takes like a funky path. There's all these deployments that they have to do. And this is like we were talking about, where things can go wrong. And the whole project can be, years of work can come crashing down with one thing going wrong. They have to deploy the mirrors for the functioning of the telescope. They have to unfold the whole thing. As we saw in pictures earlier, when it's being launched, it's all condensed. So it has to unfold, and all the the machinery on there and the instruments have to be prepared. And if anything goes wrong in those deployments, bad news.
Game over.
Bad
Game
news.
over.
Thankfully, that's hasn't happened yet. As of now, the sun shield has been successfully deployed, which was one of the biggest risk maneuvers that they have to do. And the sun shield, or sorry, excuse me, the mirror array has also successfully been deployed, which is good news.
It is. And we're going to talk in a little bit, we're going to show you a short video clip about the alignment of those segments of the mirrors, because there's 18 hexagons that are going to be operating together as one mirror to focus real sharply to get an incredible resolution to focus to the secondary mirror, which will feed back through the telescope to get to the instruments. And so you see on the diagram up next, Seth mentioned the Lagrange point 2, and there are 5 Lagrange points, and these Lagrange points are, well, let Seth tell you about it.
Well, I'll try not to bore you too much with the intense details of it, but you can see on this diagram there's 5 spots, all labeled where these points exist between 3 bodies in space, this being, in this case, the Earth, the Sun, and the Moon. And the lines here on this diagram sort of illustrate gravity, if you will, and you can see at those points, those are points where gravity, there's gravitational equilibrium created by the interaction between those 3 bodies. And the point that the James Webb Space Telescope is going to be resting at is L2, which is on the right side there. It might be a little hard to see, but it's just past the moon there on the right side of that diagram. It's about 1 million miles away from Earth, and that is where the telescope will be living.
Yeah. And just to point out, the drawing is not to scale.
Yeah, of course.
Because you can see Earth and the moon around Earth, but this Lagrange point 2 is 4 times the distance to the moon. The moon, an easy number to remember, it's not the exact average, but an easy number to remember is 250,000 miles. So if you figure the moon is 250,000 miles away, we're going 4 times that distance to get to Lagrange point 2. So there aren't going to be any repair missions going there either. So everything's got to work. So what we'll do is look at this video clip. As we mentioned, there's 18 segments of the mirror, the large mirror, 18 hexagonal segments, and they've been stowed. And what is happening now, as we're towards the end of January recording this, is they're kind of being unpacked, if you will. So they are going to be in a position where they can be moved and adjusted to get the focus that they need. So we'll watch this little video clip. So as we watch this, we see that about 40 days after launch, which is going to be roughly 10 days or so after it reaches Lagrange point 2, is when they're going to start aligning it. And if you noticed there, they talk about the fact that these mirror segments can be moved in such small increments of a 10,000th of the width of a human hair.
It's pretty incredible.
It is.
Yeah.
And so you may ask, well, how wide or what's the diameter of human hair? Well, I did some research. And it's about 17 micrometers or microns to 100 or so. So 17 to 100 microns or micrometers. So really small. We're talking,
Pretty small.
several millionths of a meter. And then you take a 10,000th of that. So incredibly accurate in terms of what it can do to adjust to get the prime focus, which it's going to be working on during the month of February.
It's really remarkable achievement. It's super exciting. We're going to get to see in the coming months and years all of the awesome stuff that this telescope's going to collect. It's really exciting.
It is. And we'll have updates, of course, on the show, as this is really exciting. As we mentioned, it's been 25 years we've been waiting for this. Well, the winter sky is up. We are in the dead of winter, if you will. February is definitely a winter month. And Seth, what's one of the, I would say, one of the iconic constellations of winter?
Well, there's a couple, but the one that comes to mind for me, and also my personal favorite, is Orion. It's a very, very distinct constellation. It's one of the larger ones, and it contains a number of bright stars. And it's got that, the belt of Orion, very common, popular asterism that you see. A lot of people will recognize that in the night sky. So it's very easy to find. If you're looking southwest in the early evening of February, around this picture here on the right is from about 5:45, I think, 5:40 p.m. on the 15th of February.
Southeast.
Yeah. So if you start looking, sorry, I think I said southwest. If you start facing southeast, southeast, that is the general area you're going to see Orion. And it starts moving across the sky towards where it sets in the west over the course of the night. So it'll eventually, if you're out there too late at night, in the dead of the night, you're probably not going to be able to see it. But if you're just out there in the early evening through the night, you get some really nice views of the stars, like Betelgeuse, a big bright red star, and Rigel, one of the brightest stars in the sky, on the bottom right of Orion. And you also have the Orion Nebula, which is, if you have a telescope, it doesn't need to be a large telescope either, or just a pair of binoculars. Do yourself a favor, go outside, the Orion Nebula, take a look at it. It's right below the belt of Orion on the left side. It's really absolutely gorgeous. It's one of the best things you can look at the night sky.
And one of the easier things.
It's not hard to find. It's very bright, the nebula itself. It's some nebulas you really have to struggle with, and you finally find it, and it's this little gray little fuzz in the sky. When you look at the Orion Nebula, you can see it really, and it's almost glowing. It's beautiful. You don't want to miss it, but it's there all month. It's just waiting for you. You just got to go outside and see it. So.
And as a matter of fact, that's kind of the image that's kind of been behind us here.
That
is
is
a close-up of the Orion Nebula.
Yeah.
So if you have a smaller telescope, don't be disappointed. You're not going to see this radiant bright color. You'll be able to see it, and it's just very cool to look at it. But it takes a large telescope or some photographic imaging to bring out the vibrant colors.
Don't get that is unfortunately not what you see when you go outside and look through your telescope. Is this beautiful, all this color behind me? But it's really remarkable. I can't recommend enough that you go look at this. And February is the perfect time. Winter time is the season for Orion.
Nice, clear, hopefully some clear, crisp nights. And In the morning, we have some treats. Seth, what's happening in the morning skies for February?
If you're an early riser, I'm not, but
I'm not either.
if you are, treat yourself. Get up early a couple times this month. Mainly towards the middle, like after the halfway point through the end of the month. If you're up in the morning, around like 5:45-ish in the morning, and you're facing southeast, look for Venus and Mars. Venus will be incredibly bright. If you're looking at it, you're not going to miss it. It's going to be at magnitude -4.8, which is brighter than any of the stars you're going to see at night in the sky. So it'll be incredibly bright. Its elevation will change during the course of the month, depending on what day you're looking, but it's going to be about between 15 and 20 degrees above the horizon. So try and find a place that has a low horizon, as Mars will be even lower as well too. Mars will be as low as 10 degrees above the horizon. So if you've got trees all in your backyard, that's probably not the best place to view. Try and find the top of a hill or a clearing.
Yeah, maybe need to go for a walk or maybe a little short drive.
But it's worthwhile. Venus is stunning when it is in its full glory, and it's incredibly bright. It's almost like a second sun coming up. Yeah. Maybe I'm being a little dramatic, but it's really quite beautiful coming up in the morning sky.
It really is. And one of the reasons it's so bright, like unusually bright, even for Venus this time around for the past several years, is the elliptical orbit of Venus is bringing it closer to Earth than typical. And it's getting within 0.41 AUs, when typically it's 0.44 to 0.47 AUs away, an AU being an astronomical unit, the distance from the sun to Earth. So it's close to the sun, it's close to Earth, it's enshrouded in clouds, very reflective. We say it has a really high albedo, and that nets to really, really bright. And I did a little calculation earlier, and the brightest star, which I'm going to be showing you momentarily, where to find it, Sirius, is the brightest star in the night sky, and Venus is shining 25 times by actual mathematical calculation, 25 times brighter than Sirius. And I'm serious.
Yeah, see if you can catch your shadow from
Yes,
Venus,
yes. It's been told that Venus casts a shadow. And another thing that you mentioned in the last point here, which is very cool,
right.
is what?
If you're looking for a real challenge, and you have the equipment for it, you can observe Venus in the daytime. I have not done it personally, and I can imagine it's not the easiest thing to do. So not a challenge for the faint of heart, if you will, but if you feel like you want to challenge yourself and you have the equipment to do so, try looking at Venus during the day. It'd be pretty cool.
I must tell you, I must confess that I have taken my STEM class out, and we've done it.
Yeah?
Yeah, we've seen it. And so the only real equipment you need are your eyes. Binoculars can be helpful, but by all means, you want to stay away from looking at the sun.
It's a dangerous game.
So I'd wait a little later on in the month, give Venus some time to get some distance away from the sun. But it is really, it's a neat challenge to look up at noontime, to look up in the blue sky and say, oh my goodness, there's Venus. Because it's kind of one of those things that once you find it, it's like you can find it again. But the first time finding it, it's tough. But it's a fun challenge. Well, awesome. Well, Seth, thanks so much for being part of our show again and talking about James Webb and Orion and Venus and Mars and these neat things we get to see in the morning sky. All right.
Yeah.
So
thank you for having me.
You're welcome. Best of luck getting back to college and getting the books again.
Thank you.
All right. Well, we're going to take a look a little closer at the night sky, and I'm going to share with you how to use Orion to find the winter hexagon. So here we are. We're looking in the morning sky, and as Seth and I both agree, we're not morning people, but it's going to be worth your while. So I chose February 14th, Valentine's Day, because it's an easy date to remember. And so if it looks like it's going to be cloudy on Valentine's morning, you know, the 13th, the 12th, the 15th, the 16th, it's all good. But what you want to be looking for is 3 planets. Venus, blazing bright. You cannot miss it. Remember, a negative 4.9 magnitude, 25 times brighter than the brightest star in the night sky, Sirius. And then you have the planet Mars, shining at a modest 1.4 magnitude, and Mercury is moves really quickly. So you have to have a look at it right in this realm of 12, 13, 14, 15, 16, those dates to find Mercury. And you can see it's really close to the horizon. And we're talking about 45 minutes or so before sunrise here. And Mercury will be very bright, magnitude 0, but it's in the glare of the sun. If you have some binoculars or get some binoculars, that'll help you a lot to find Mercury and Mars in particular. Venus you cannot miss. So this is going to be a great opportunity. February, the morning around 6 o'clock, February 12, 13, 14, 15, 16, in that realm to see these 3 planets making this very nice triangle. Okay? All right, let's move on to the dead of night, if we will. Well, a friendly time at night. We're talking 8 o'clock at night, mid-February. This is February 17th. Should have kept it the 14th, but anyway, I went to the 17th, kind of more in the middle of the month. And what we have here is the constellation of Orion that Seth talked about earlier. And you can see the belt. I love to say the 3 star names of the belt, Al-Natak, Al-Nalam, and Mintaka. Up at the upper left, as you look at Orion, is the star Betelgeuse, red, and the red stars are the cooler stars. And as we look at Orion, the bottom right is a blue-white star, Rigel, and the blue-white stars are very hot. But we have a variety of colors to show you, and we're going to show you the hexagon, and we're going to take Betelgeuse to be near the center-ish of the hexagon. We're going to start with Rigel. From Rigel, we're going to go up to an orange star, Aldebaran, which represents the eye of the bull, and you can find that easily by taking the 3 stars in Orion's belt. They pretty much point up to the bright orange star, magnitude 1 of Aldebaran, the face of the bull. And then we keep on going pretty much to an overhead position, the star Capella. And the star Capella is a yellow star, a class G star, much like our sun, and it is a magnitude 0. So the same brightness as Rigel, but you can definitely tell the difference. Betelgeuse also hovers around a magnitude 0, not quite, but so similar brightnesses. And then from Capella, we come over to the twin stars, Castor and Pollux, and we're just going to pick on Pollux for our hexagon here, but the 2 twin stars are Castor and Pollux. And I remember, well, which is which, Castor or Pollux? Well, Castor begins with a C, and Capella begins with a C. So the 2 C's are close to each other. That's how I remember the difference. And then we come down to Procyon, or Procyon, some pronounce it. Procyon is the little dog star, the brightest star in the constellation of Canis Minor, the little dog. And then we finish with Sirius, the brightest star in the nighttime sky in either hemisphere, negative 1.44 magnitude. And that completes our hexagon. So let's look at the next image. And just thought we'd keep the stars in the same place, but show you the constellations. We know Orion is the hunter. We've talked about that. Taurus is the bull, Aldebaran representing the eye of the bull. Capella is the brightest star in the constellation Auriga, the charioteer. And then we have Castor and Pollux, the twin stars. These stars typically represent the eyes of the twins, or the head or the neck of the twins. And again, Castor begins with a C, Capella begins with a C. That's how you can remember which one is which. Castor and Pollux are the twin stars. We're going to use Pollux for our hexagon. We come down to Procyon, the brightest star in Canis Minor, the little dog here, and then down to Sirius, the big star the big dog star, Canis Major. But notice, just it's worth pointing out because everybody notices, what's a unicorn doing there? Well, that's the constellation Monoceros. Who knew there was a unicorn constellation? But there is. As you look at Orion, to his left is, as you look at Orion, is Monoceros. So this is, again, we're looking 8 o'clock, February 17th. And if we look at the next picture, I kind of drew out the hexagon for you here in the next picture. And we have Betelgeuse kind of at the middle-ish of this hexagon. And you can see it's not a regular hexagon, but it does have 6 sides. Rigel, bluish-white star. Aldebaran, orange. Capella, yellow. Pollux is white. Procyon is white. Sirius is a bluish-white color. So you can enjoy the colors. Now you know some stars, constellations they go with, and easy to find Orion as a jumping off point to do your star hopping. Okay, next on our show, I want to take you to February 27th, and Seth mentioned this earlier in the show, but we have a treat on the morning, 6 a.m. of the 27th, where the moon joins in. Now here it looks like the moon is full. It's not. It's really a very slender, waning crescent moon. But Venus, you can't miss. Mars, we've talked about, and we have the moon. But notice now we've had enough days go by that Saturn is starting to make an appearance right near Mercury. And so Saturn, over the months to come, will be getting higher and higher. But this is really pretty much your first glimpses of Saturn since it moved from the night sky into the morning sky. And so this is February 27th. On the 28th, the moon will be a little lower down here. The other planets will be in about the same spot, but the moon will be even a little more slender crescent and closer to the horizon. 6 a.m., who's brave enough to get up, brave the cold? It's going to be worth it. Bring your camera, okay? So that's what we have. It's been a great show. I hope that you enjoyed it. And the month of February has a host of all sorts of things. And keep an eye on the James Webb Telescope. We'll be giving you updates on that. So I'm your host, Dave McDonald, for the Sky this month.